Okay, vanakkamba, good morning.
Good morning, sir.
Good morning.
Good morning, sir. Good morning.
Vanakkamba. Okay, very well. Okay, let us continue this last class discussion. We are seeing about uh, sulfuric acid production and sodium carbonate or soda ash production. Okay. I thought of discussing you about this. Why it is called as this contact process is also called as double conversion, double absorption process, or simply called as DCDA process. DC, double conversion, or this conversion is also called as double contact, or is double conversion, double absorption, or double contact, double absorption. Both are referring to the same. The contact is actually happening in the converter. There is double conversion or contacting are happening in the converter. Why it is called as a double conversion? So let us try to understand that terminology. There is a most common process is called as a simply contact process. It is also named as the double DCDA process. You can now ask, since there is a DCDA process, there will be also a single absorption, single contact process. Okay, there is what is called as SCSA process. Definitely you can expect this DCDA process can have more conversion. That means all the sulfur entering is turning to all the sulfur is turning to sulfur trioxide. Sulfur is turning to sulfur dioxide. Of course, it is a very fast reaction. It is a what is it? For highly exothermic forward reaction, whereas SO2 to SO3 is exothermic reaction, but it is a reversible reaction. So otherwise, here this SO2 to SO3 may not be to make that to conversion to a higher level. We need to have multiple contacting. The multiple contacting is needed because in a single contact, if you try to achieve the process, it will lead to production of very high, enormous temperature because of the exothermic reaction. But this higher temperature is not favorable for this reversible reaction. Higher temperature is not good for reversible exothermic reaction. The equilibrium conversion is limited. That's why what we are doing, we are carrying out this in stages. By the way of carrying out this in stages, we have this, we could limit the reaction temperature. See, let us try to understand the diagrams here. ஓகே எத்தனை பேர் இருக்கீங்க? ஒரு மினிட், ஐ வில் செக் இட். நோ, ஒரு 40 பேராக இருந்தீங்கன்னா பெட்டராக இருக்கும் இல்லையா? About good number, 49, 48 students are available. Good. See, of course, there are catalyst beds in the converter. Catalyst is vanadium pentoxide over some ceramic coating, ceramic beads. This vanadium pentoxide material is available. This ceramic beads over which V2O5. No? V2O5 is a costly material and we cannot employ fully V2O5. It is simply available as a coating because only on the catalyst surface the reaction is happening. So it is not, the reaction is not going happening at the this interior of the V2O5, no? Only at the catalyst surface. So we need to have a coating. It's enough to have a coating of V2O5 over the ceramic beads. Okay. Here this inlet feed gas is, okay, let me slightly zoom it. 1 minute. Yeah. So the feed gas is sulfur dioxide plus of course oxygen. SO2 we need only about half of O2. No? So 1 mole of SO2 needs half mole of O2 to turn that to SO3. But still we send excess amount of oxygen. Again, this is to ensure that all the SO2 is turning to SO3. So otherwise, wherever the conversion of the this very essential component, no, SO2 has to be converted. So whereas this O2 we can supply in excess, so that all the essential component will be converted. Okay, so otherwise we have excess amount of oxygen entering. Okay, how much is the percentage excess? This and all we'll try to get an idea in the coming second unit, which is giving an idea about the stoichiometry calculations. Okay, so it is entering at a temperature of 420. and there is a conversion happening. SO2 is turning to SO3. Out of here, only about 63% conversion is happening, and there is a temperature rise to a level of about 600, whereas equilibrium reaction is favorable only at a temperature of the order of lesser than 500. So what we are doing, so whatever the gases leaving this first bed is going to the heat exchanger, where in which it is getting cooled, and the cooled is gases, reaction gases is again passing to the second bed. It's again entering at a temperature of 450. Again, it is getting rise to a temperature of 510 because of the reaction. So there is now a slight increase in conversion from 63. It is going to a conversion of overall conversion of 84%. So, okay, this first two in the first two beds, the heat removal is happening by a heat exchanger. So in the heat exchanger, of course, normally the cooling water will be sent, and according to the temperature level, it may turn into steam or this water. Here it is turning to steam, and it can be again coupled to the S to SO2 conversion. So this whatever the heat generated will be used to rise steam that will be passing to the waste heat boiler coupled to the sulfur burners. Okay. After this second bed, again you see this temperature is here it is 510. It is again reduced to 450 because of this intercooling. Then here 450 it is rising to 475. So you can see the temperature rise is slightly lesser in comparison to the first stages, because large amount of material is available. Here 84 to 93%. That means only about 10% of the metal is getting converted. So that's why you can see that temperature rise is also not that much. This heat generation is in proportion to the amount of material getting converted. Okay. So 475, this the gases leaving this reaction bed 3, bed 3 is going to the intermediate absorber. Otherwise, we have this absorber. Absorber is nothing but your this final reaction, which is SO3 combining with oleum, so combining with concentrated sulfuric acid to turn it to oleum. Yeah, so that it is going to the intermediate absorption tower, and again the gases leaving from the intermediate absorber again going to the final bed, fourth bed. So otherwise, till this is for the first bed, second bed. The second bed is simply going to the third bed. This third bed contents are going to a absorber. Otherwise, till this third bed, we'll simply take it as a single contacting. Of course, though there are three beds, and so the contacting is simply taken as single. In between, the cooling is simply to reduce the temperature. And this the contents leaving from the third bed is going to the what is called as a primary or intermediate. Primary, or it is also called as the intermediate absorber. And so the amount of sulfur trioxide remaining here or available here are getting converted there in the are turning to oleum in the intermediate absorber, and still unconverted will go to the this reaction bed, fourth bed. So always one conversion is over, the second conversion is happening in the fourth bed. So till the first third bed, it is to be single contacting, and otherwise though there are contacting in three beds, till then we can till then the concentration of the condenser keep on rising. From the third and fourth bed, you can see there is a the gases entering this fourth bed will be always having lesser amount of SO3 in comparison to the previous stages, because a large amount of SO3 is getting absorbed in the intermediate absorber. So whatever that is remaining still will be converted in this fourth bed. So by this way of four bed contacting, we could have a conversion of overall conversion of 99.5%. That is only about 0.5 percentage of O2, 0.5% of the feed sulfur is not utilized. Okay, that is what is the meaning of this 99.5% conversion. So this final absorption again, it is again with this contacting with sulfuric acid will be converting into oleum. Otherwise, there are two absorption and also two conversions. Two conversion are also called as two contacting. So that's why it's called as double contacting and double absorption or DCDA process. Okay, you should know about the name reason for this name. Whereas in the single contacting, single absorption, this all that is converted in these multiple beds will be going to the going to the absorption. There is a final stage of the reaction, there in which will be contacting with sulfuric acid, and that will turn to oleum. By that way, we could not have this conversion to a level of about 99.5 or even still higher. Otherwise, single contact, single absorption is not giving you the higher overall conversion. Okay. Otherwise, a modern process are simply double conversion, double absorption methods, or is simply called as DCDA process. Okay, this I thought I have in covered in the last class. Likewise, the next aspect of in the these are all available in this detailed flow sheet. இதில் பார்த்தீங்கன்னா ரொம்ப கன்ஃபியூஸ் ஆகிடுவீங்க. Let me try to explain this to the extent possible. So we have this sulfur or is molten sulfur. How to get molten sulfur? This sulfur powder is available. We can circulate steam. Of course, steam you can get from this what is it, the heat removal in the converter. No, so the whatever heat removed the converter can be circulated here to get this molten sulfur. So which is sent to the burner or furnace, where in which large amount of heat is getting released because of the highly exothermic nature. So there is a waste heat boiler. So we could get this steam. Of course, it is available. Everything is available in terms of BTU. So what is BTU? British thermal unit. Okay, that's like kilojoules. We can there is a conversion factor between kilojoules, kilocalorie, and BTU. Okay. So waste heat boiler, and again say whatever the here also no. So whatever is leaving from this converter passing through this waste heat boiler, and what is passing here? SO2 and O2. This SO2 of 10%, O2 of some 12%. The rest is simply nitrogen. Yeah. So this nitrogen is about 75-80%. So this is going to a converter which is 4-bed converter. So this 4-bed converter is very common in chemical this sulfuric acid industry. Okay, this bed is having vanadium pentoxide coating. Okay, what is it is the reaction is happening in the first bed, and the contents are passing through a heat exchanger so as to reduce the temperature. Of course, it is also generating heat. Say here, whatever the heat leaving from this waste heat burner can be raised off its temperature. What is called as, this is called as the superheating of the steam leaving from the what is it, the primary process, or what is sulfur dioxide process. Sulfur to sulfur dioxide, no? There is generating large amount of heat. This steam is converted into a superheater steam. So it is called as superheater. So this contents leaving from this superheater is going to the second bed, and again we have this heat exchanger here. In comparison to the first bed, second bed heat release will be lesser because about 65% conversion is happening in the first bed itself. So otherwise, entering material, 65% of the material is turning to SO2 is turning to SO3. Next, we have only about 35% material. So from that material, the heat generation will be in lesser, only about 1/3 of the heat generated here. That's why here there is no steam generation. Simply we can use the water to cool the contents. Okay, there are don't worry about this direction at all. We'll discuss this in the heat in the third unit, which is about heat transfer. Okay, so here The second bed material is leaving, going through a heat exchanger, and it is going to the third bed. Where is the third bed? Yeah, this is the third bed. And this third, the materials leaving from the third bed is going to what is called as a intermediate interpass absorption tower, and again it has to come to the fourth bed. Of course, there are a lot of loops here. So from the fourth bed, it is going to a final absorption tower. This is very detailed flow sheet. Of course, industrial process will be much more complex. Pathina, they'll normally this any chemical industry they will have what is called as heat integration. So any heat leaving the process should not be wasted. So they will try to utilize the heat for any process which is in need of that. And also this water will also be passing through lines. So the cooling water is needed for this line. So this cooling water need not be taken from a pump, and only it has to pass through only this equipment. So this whatever the water leaving this heat exchanger can also pass through any other equipments, and it can further remove the heat. So that with a single pump we can take multiple removal of heat at multiple points. Otherwise, we cannot use for each and every fluid a separate pump. From the single source of water supply, it will pass through multiple equipments and remove the heat. That's why this process is so complex to understand. Whereas if you see the real industry, it will be much more complex. Okay. Of course, ideas are simply to wherever the temperature there is a heat generation, send fluid which is capable of taking the heat. The requirement is there should be a delta temperature difference available between the high temperature source and low temperature material. If there is a temperature difference, there is a heat transfer possible. Okay, so with that we can easily achieve the necessary heat transfer. Okay, next thing is sulfuric in the sodium carbonate production. We have missed certain aspects. Yeah, even the sodium carbonate, I haven't discussed about this point, like what is called as a naturally occurring ore in the US, what is called as trona. Trona is a material which is sodium bicarbonate. Simply by heating these contents, we can get sodium carbonate, which is available in large deposits in what is it? This place called as okay, this Green River, Wyoming. Okay, in that this is available in plenty. So that's why thereby they are getting this sodium carbonate easily. Whereas in our country, we don't have such trona deposits. So we are getting this by this process, what is called as Solvay process. Now the original Solvay process is using calcium carbonate and sodium chloride to get sodium carbonate. Of course, there is a cyclic intermediate, what is called as ammonia, because sodium chloride and carbon dioxide are not reacting easily, whereas the ammoniacal solution of sodium chloride is easily getting reacted with carbon dioxide and to get sodium carbonate. So that's why we have ammonia as the cyclic agent. So which is leading to generation of ammonium chloride. To regenerate this ammonium chloride back to ammonia, we are using this lime. Of course, lime is where it is obtained. This calcium carbonate is originally used to raise carbon dioxide. Along with that, some form of coal or some form of carbon is also used because to initiate the reaction, and also to generate some amount of extra amount of carbon dioxide. Okay, so this coke or even the process, even the materials like naphtha or any petroleum components can be burnt to generate carbon dioxide. So I said in that connection, I said about this spic and what is it, tack plants nearby in the Thoothukudi region. Thoothukudi in Spic Nagar, we have this from to the south of Thoothukudi, we have this pig plant, which is a very huge industrial complex. Nearby, we have Thoothukudi alkali chemicals and some other industries as well. Of course, pick and tack are the same management. So this PIC, they are getting this raw material which is simply naphtha. For naphtha is for getting this carbon dioxide. Of course, you can think of carbon dioxide is available for free in the nature, but a highly concentrated, large amount of carbon dioxide we have to generate definitely from a carbon source. So the carbon source, the clean carbon source is liquid, petroleum liquids, simply the naphtha. Of course, now this process, no, this getting urea from this naphtha is relatively costlier in comparison to this getting urea from what is it? This uh, liquefied natural gas, what is called LNG. So once the LNG connection is connection were given to the various places. Normally, it was easily available in the places like Gujarat. So once that LNG connection were given, this pig plant became what is it? Or is the cost of production of pigs was found to be higher than the cost of other plants. So that leads to even shutdown or closure of this urea production. About 10 years back, this was a situation in Speak. Whereas 25 years back, even I was trying, or I taken up this chemical engineering just because of this good employability in Speak. I am from this Thoothukudi region, and about only for about 40 kilometers from my village. So with that idea, even I chosen this branch. But after about 10 years, no, from the in the period of about 2005 and all, this Speak the urea produced from Speak was found to be highly cost. The cost of production was highly very high in comparison to the other plants in the India. So that leads to the even closure of the urea plant in Speak in Thoothukudi. What they did not say, they simply even purchased urea from the other parts of the country, and even they have simply packed the contents and sold in that name of the Speak urea. That also happened. The reason for that is urea produced from naphtha is highly costing in comparison to urea produced from LNG, because LNG process is a gas based process, and these gas based reactions are highly effective in comparison to liquid based reaction. In this connection, you can also say that the solid based reactions are still less effective in comparison to liquid based reactions. Okay, otherwise whatever the plant you are putting, you cannot expect that to be long lasting. Because always a competition from the new raw materials coming out, or a new kind of process getting developed. So these are all the ideas better to know. We should know about. Otherwise, we should always look for a variety of end users for our product. Not only that, variety of starting materials. Of course, we cannot easily change the raw material because the processes are designed for using naphtha. Whereas if you are trying to use LNG, again you have to make a lot of modification. So you should be ready for making that modification. Then only the process can survive. Then only the industry will be economical. Okay. Of course, still urea is getting produced, but it is not as effective as the urea from LNG based processes. The LNG connection is not there in Thoothukudi. Whereas it's there in the Arabian Sea region. Whereas Gujarat, there is a connection. Likewise, even Cochin may also have connection. Whereas Nama side varla. Okay, these are all some idea about in connection with this carbon dioxide. Okay, so carbon dioxide is obtained from any carbon source, clean carbon source, which is coal or coke or uh, uh, petroleum. Of course, you can also get from this liquefied natural gas. Okay, LNG. Okay, now further continuing, this single step process is much better in comparison to the regeneration of ammonia. In what way? Because we are utilizing this ammonium chloride as a product. So this 2,2-guanine alkali chemical is simply selling this ammonium chloride as a fertilizer. Even you can think of this. There is a plant near this Metur, no? Chemplast Industries, which is a group of Sanmar chemicals. People near this Salem can try to visit this plant, which is at Metur, no? Sanmar chemicals or Chemplast Sanmar. They are also producing this sodium carbonate. Not only sodium carbonate, they also produce supposed to be sodium hydroxide also. You please check that. No? Okay, this is a single step process: sodium chloride, ammonia, carbon dioxide. So this carbon dioxide for the 2-degree alkali chemical plant is simply obtained directly from this pick. Of course, this carbon dioxide is the raw material for urea. So whatever the CO2 generated for the urea production, the extra amount is supplied to this 2-degree alkali chemicals, which is producing sodium carbonate and ammonium chloride. Okay, because of that, they don't need. There is no need to generate carbon dioxide in that process. Otherwise, the idea of saying this is the industries, if they are sharing the same kind of chemical, we can avoid some certain equipments. Thereby, your investment will be reduced, and also you'll be getting some clean source of fuel, clean source of material. So otherwise, better to have a cluster of chemical industries instead of isolated industry. If the industries are available closely, even whatever the heat generation from one of the industry, if it is generating excess amount, that can also be given to the nearby industry. Even you can also think of these power plants, no? The power plants are generating larger amount of carbon dioxide. Now, how do they generate carbon dioxide? Why do they generate carbon dioxide? Because they are simply using this fuel, which is carbon based fuel. So mostly coal. Coal is turned to carbon dioxide. So the large amount of carbon dioxide is available, which is simply left to the atmosphere. Whereas instead, if you can think of putting this what is it, sodium carbonate plant near the power plant, there is also a huge saving. Otherwise, we can avoid the cost of carbon dioxide. Okay, that way we can also utilize this carbon dioxide from the power plants, and it is converted into a valuable product, which is simply sodium carbonate. So otherwise, these are all ideas, but how to implement this practically, this and all we have to work out. Okay, ammonium chloride is regenerated by adding this lime, which is calcium hydroxide. Of course, limestone, lime, or it is also called as milk of lime, and quick lime. So there are varieties of name for this calcium oxide chemicals. That and all you please go through. Okay, brain and time. I need to discuss the another topic as well. So the brine is, will again summarize this process. Brine, which is nothing but sodium chloride, concentrated sodium chloride solution of the order of about 300 grams of sodium chloride in a liter of solution, which is entering this ammoniation tower, there in which ammonia is entering, passing from the bottom. Always send the gases from the bottom, so that the gases will rise from the bottom, and it will have a good contact, and send the liquid from the top, so that we'll be having the liquid will pass by gravity, pass due to gravity, because it's having a higher density. Okay, and this contents are again passing to a carbonation tower. It's a liquid solution, and carbon dioxide is passed from the bottom. So we will be getting ammonium chloride and sodium. What is it? Sodium bicarbonate. So sodium bicarbonate will be sent to a process what is called as calcination, and there in which simply heat is added, and sodium carbonate is coming, and carbon dioxide also will be recovered. So this ammonium chloride, if there is a if it can be sold as a product, we can directly send that without needing this ammonia recovery step. Okay, and also if CO2 is available from a nearby plant, we don't also need this CO2 generation. It's very simple steps. Okay, so these are all how to recover the ammonia. To recover the ammonia, of course, we have this. What is it? We are using the steam, which is passing through this what is the reaction? Reaction is ammonium chloride is turning to ammonia just by using this calcium hydroxide. So we have ammonia which is living in the form of gas. Here, to effect this process, or is to in this process, we are sending steam as well. So that's why we are sending a steam, so that this all this available ammonia is living in the gas stream. Okay, here there are some ideas available here. So let us try to answer these questions. So what is the need for excess air? So that all the sulfur is turned into end products. Still, we have a conversion of only about 99.95%, or 99.5%. The 5% sulfur is still leaving, or still living in the form of sometimes sulfur dioxide itself, or sulfur trioxide. It is living in the gaseous, in the flare. And how is the heat released from the sulfur to sulfur dioxide and sulfur trioxide reactions are recovered to convert to steam or to electricity or to any hot water. So what is the reason for having SO2 to SO3 in a 4-bed instead of a single bed? So in a single bed, if you try to do the conversion, what will happen? It will generate very huge heat, and also the conducting won't be efficient. We won't have higher conversion. The higher conversion is not possible because of higher temperature it is reaching, and equilibrium reaction will go to the backward direction. So that is also the reason. Instead, if you try to remove as and when this SO3 is getting formed, you can always force the reaction to the forward. So that's why we have this multiple contacting. Reaction is happening in multiple beds, normally the 4-bed. Of course, you can think of going for 5-6 beds, but it will again add to the equipment, increase the equipment size. That is not found to be suitable. Always, each and every bed you have to remove the heat and again bring it back. So these are all not found to be viable. Industrially, this 4-bed contacting is found to be very good. For the conversion of SO3 to sulfuric acid, why we are using sulfuric acid, not water? Because
Low vapor pressure, sir.
nice. Not thanks, ma. Thanks for very closely following. Not only this low vapor pressure, and also we can also say in terms of
Formation of mist, sir.
mist. Good. And also the mist is also coming because of the exothermic nature of the reaction. SO3 to sulfuric acid. With SO3 plus water, if you add, it will be generating large amount of heat. Again, there is also exothermic reaction. All the reactions in this sulfur to sulfuric acid are highly exothermic reactions. Of course, the first reaction is very exothermic. Per mole, 300 kilojoules is generated. The next one per mole, another about 100 kilojoules. This again, SO3 plus water is also exothermic. So exothermic means again it will be leading to generation of heat that will lead to vaporizing the products. So the mist formation is happening because of the higher vapor pressure of water in comparison to sulfuric acid, and also this SO3 plus water is exothermic in comparison to SO3 plus H2SO4. Okay, there is another reason we could add. Thanks, Ma. Thanks for closely following. Okay, these are all with respect to sulfuric acid. And next is about why sodium carbonate is called as soda ash. So originally ash is the material for what is it? Potassium. From this potassium means potassium carbonate, K2CO3. Yeah, right. Which is from plant materials. Burning of plant material is getting this potash. The similar way, sodium bearing plants which are growing in the saline region can also be utilized for producing sodium carbonate. Of course, that can be used for some smaller amounts of products. Whereas we are using this sodium chloride to sodium carbonate process. Sodium chloride is utilized as a raw material. Still, to resemble this potash, we are having this soda ash. Ash is simply obtained from the burning of the plant materials. In a similar way, this sodium carbonate can also be produced. That's why it is called soda ash. It was a historical way of production, but for large scale requirement, we cannot use that way. And what is the role of ammonia, which is a cyclic agent, and it is to facilitate the faster reaction between carbon dioxide and sodium chloride. Sodium chloride and carbon dioxide will react, of course. That is what is a natural reaction happening in the ocean. No, ocean is also a great sink for carbon dioxide. Now, people are saying about this carbon dioxide, which is leading to global warming. So, whatever the carbon dioxide released because of our this power production. No, power production is conversion of carbon to carbon dioxide that is left to the atmosphere. So whatever the carbon dioxide left to the atmosphere is of course taken back by the plants. They are converting that carbon dioxide into the nice products, say our food products. Still large amount of carbon dioxide is utilized or simply absorbed by the sodium chloride in the ocean, and it is turning to sodium carbonate that is leading to it is again the material for your aquatic organisms. So your the fish shells, they also have this sodium carbonate. So there is this a natural mechanism to convert this carbon dioxide back to to fix the carbon dioxide to the atmosphere, to the liquid form or solid form. Okay. And how is the original process modified to overcome the pollution of calcium chloride? So the original process of Solvay process is simply using calcium carbonate and sodium chloride to convert into calcium carbonate plus sodium chloride to convert that into sodium carbonate and calcium chloride. But that process is actually giving this calcium chloride as a byproduct. So this byproduct is not having any much value. So we have to think of disposing of this chemical. Instead, if we can have this process, otherwise if there is a requirement for this ammonium chloride as such, we need not use this calcium in the process. Otherwise, calcium is not only for the generating calcium carbon dioxide, it is also for the essentially for the recovery of ammonia. This ammonium chloride is turning to ammonia by this step. Ammonium chloride plus calcium hydroxide is turning to calcium chloride. So this calcium chloride is, though the reaction is appearing simple, but this is not happening as such. There is a ammonia involved in the process. So since the ammonia is there in the feed and ammonia product, we haven't shown in this reaction. Otherwise, the detailed reaction, it will be forming to ammonium chloride and ammonium chloride. Otherwise, this you have to write in terms of 2-3 steps. Okay, that we haven't written here. Of course, chemical process industry, there is a course in your third or fourth semester, that in which you will study that in detail. Okay, no need to worry now. So idea of these two industrial production is to give an idea about the large scale production and how they are happening in the industry, and why there is a recycle, or why there is a or is how the process are happening, or is how this gas is passing and liquid is passing, the direction of contacting. So these are all to give idea for these things only. We have taken up these two processes. Of course, the detailed contents detailed contents will be discussed in your course, what is called as chemical process industry in your course, which is a core course. Of course, what is core course and elective course? This core course means these are all the essential contents you cannot avoid. Whereas elective, if you don't study that elective and if you choose some other elective also, you can still finish chemical engineering. There is elective courses. Okay, there are a lot you can go through in your syllabus. Okay, now I should go to the next aspect because so much time left. Another about 20 minutes maximum, 15 minutes. Yeah, I will go to there are varieties of flow sheets available that you can go through. I will go to the next aspect. Okay, always we'll see the contents for this thing. These are again the lines from your syllabus book. Introduction to chemical engineering, chemical process industry, history and role. In today's class, we'll see about the roles of chemical engineer. and also if possibly is in comparison with chemistry and chemical engineering, in comparison with other engineering, how it is different. Of course, though you have an idea, let me give my own idea. Okay, synthesis in chemical normally happening in the chemist lab. Always these steps, no. See what is happening till this. Okay, this entire thing is happening in a chemist lab. So you can take this raw material in a test tube and bring it to necessary temperature and send to a reaction flask. And if the product is having some any impurity, you can separate them by a distillation setup. So this is simplest kind of setup you will be having in a laboratory. Whereas this way you can produce chemicals of that of about few grams per day. So at the most you can produce some 20-50 grams. Whereas we need of that of about 20-50 kg per second. Whereas this is happening in a whole day, no. So for that, how do? We have these materials in the tanks and they are pumped, and we need to add some heat or remove any heat. So for that, we have a heat exchanger, which is also a bulk equipment which will even occupy your entire house size. What is called as a heat exchanger. There will be fluid will be passing through one side, and the another coolant or heating fluid will be passing in the other side. That means we'll be having a set of tubes through which one fluid will pass, and another set of tubes through which the another fluid will pass, by which you can effect heat transfer and sent to a reactor. So reactor will be a huge equipment, sometimes occupying size of your room. And again, this contents are to be separated, because we cannot expect always this 100% conversion. Even this industrial production of sulfuric acid, even with this double contact and double absorption, we could have only a 99.5% conversion. So that means there are still the other products getting formed. But in this sulfuric acid production, this it's a liquid product and the gaseous effluents are leaving. So there is no such separation actually available. So whereas in any organic chemical industry, we'll be having a separation unit, normally a distillation column. Okay. So this is a you can now easily differentiate between chemist and chemical engineering. So here, in comparison to the previous, here this we are spending more energy for this heat exchanging or for transferring the fluid or even to separate the contents. So for this, you have to send a fluid from the bottom. Otherwise, we need to send a gas from the bottom and liquid. We have to cool the contents from in the top. So a lot of physical steps are available, which means cooling and heating. Cooling and heating doesn't lead with any chemical reaction. So otherwise, these are all physical operations. So these things are happening in a chemical industry. Whereas in a chemistry lab, you do not worry about that large scale physical operations. So because you have a very limited quantity, you do not worry about this heat removal or heat addition. Simply they are happening naturally, easily. Okay, the idea is given. Now let us see the opportunities. Of course, most of you or all of you have chosen this chemical engineering because of wide employment opportunities. In this connection, even I can say about this my during my college days. No, we used to have we used to see people. You won't normally see any girl students studying this chemical engineering or mechanical engineering courses. Of course, mechanical engineering, even in the current time also, very rarely girls are taking up that course. Whereas in chemical industry, we could see girls are as much as about 30-40%, and in your batch it is as much as about 45% girls are available. The reason is there are a lot of employment opportunities for chemical engineers. As you also know, the opportunities are in biotechnology, and major things are in pharmaceuticals. This India is a great hub for this pharma. No? The world pharma is all these pharmaceutical intermediates are normally mainly from India. Not only that, what else? This even banking industry also you can go. What is the job of a chemical engineer? Banking and insurance, because you have to assess the chemical industry, and also any insurance assessment you need to have a chemical engineer. Of course, finance, marketing, okay, a lot of things. Even the sales aspect of chemicals, no. For which you need not be in the chemical industry, you can very well there in a city, and you can do that. What is it? Marketing business. Of course, chemical engineers are getting employed in plastic production, metal production, and equipment fabrication. Of course, my first job was in chemical equipment fabrication. I worked in this chemical process plant construction and chemical chemical production of chemicals. My first job was in chemical equipment fabrication, and second job was I was 1 year here in plant fabrication, equipment fabrication, and second 1 year in what is it? Chemical production, which is sodium hydrosulfur production in Tamil Nadu Chemical Products Limited at Karaikudi. And of course, in the recent more than what is it, 13 plus 6, about 20 years I'm here in education sector. Okay, whereas people are also getting employed in information technology. Of course, IT relevant to chemical software. There is a lot of scope. Otherwise, whatever the chemical industrial production, you can also try to simulate this thing, or you can try to uh, create a scenario with the software contents itself, and you can calculate the amount of materials required, and also you can also get to know about the safety requirements. So these are all the job of this IT in always in combined with IT we can always we can also get employed in IT sector, which is developing chemical engineering based software. So one of the nice software you will also see is what is called as Aspen Plus, which is a nice software which is used to simulate chemical process. So in that sector also you can have a employability. And process equipment manufactured, of course, is also a construction of plant, and it's about equipment manufacture. These are all related. And this recently we are having this employability in water industry. Of course, 25 years back, we didn't expect this water to come in this water bottles and sachets. Otherwise, earlier water was considered to be safe. Whatever the water available in the taps, you can simply take, or whatever the water available in the open pond, also you can take. Of course, I can say about my village, and till my schools, or still my even till I finished my college, we used to take water from the pond in the village. Service kolam, yeah, kolatu tannir. We used to simply take the water without much treatment, or we simply take the water and keep the water in the pot, and we used to take the water as such, drink the water as such, without even heating. Even we were safe. That means whatever the water available was not much having not much contamination. Of course, it is simply the runoff water from the nearby fields. There is a canal connection, and in the canal, of course, you can have a lot of other solid residues also. Still, whatever the water available in that pond was considered to be safe, and we are simply drinking and surviving with that water only. Now, any corporation water people are not directly taking. They are having taking this to treating that with reverse osmosis or heating. So otherwise the feed water is not safe now. Otherwise people have a fear over the water, though it may be safe, and people we cannot easily overcome our fear, no. uh, that's what is now killing in this corona. More than the fever killing the people, fever affecting the people, this fear is affecting them a lot. So don't worry about that. You always think positively. So this water is a huge industry now. This water is 1 liter of water is about 15 rupees, and half liter of milk is also 15 rupees. So that water is that costing now, costly now. This environmental production and recycling, because we are also generating large amount of waste. Not only this chemical waste, these electronic wastes are now huge. So say your cell phone, no, you don't use this cell phone not more for more than 3 years. You are simply giving to your people, or simply it is getting dumped in the this dump yards. Or if you go to this place like Perungudi dump yard, any of you visited this place from Perungudi to Pallavaram or Perungudi to Kilkatalai? நம்ம சுவாதி கிருஷ்ணா மே நோ திஸ் நோ ஆர் நம்ம இந்த படம் பாத்தீங்களாப்பா நம்ம எந்திரன் ஃபர்ஸ்ட் ஒன் they used to say about this பெரிய you can see the mountains mountain of huge mountain between this
yes sir
பாத்தீங்க ரைட் மா சுவாதி not only everyone please try to go through this road no from Perungudi to Pallavaram what is called as loop road ring road people used to say that என்ன ரோடு அது
ரோட் நேம் கரெக்ட்டா தெரியல சார் எனக்கு பட் எங்க வீட்டு மொட்டை மாடில இருந்து பார்த்தா you can see
பார்த்தாலே தெரியும் கரெக்ட் ரைட் சைடுல ஃபுல்லா ஒரே டம்பிங்கா இருக்கும் லெஃப்ட் சைடுல பாத்தீங்கன்னா still some water is there.
Yes sir.
Of course there is a very nice marshland Pallikarni marshland but it is simply now utilized for dumping the waste. This South Chennai waste is dumped there. Likewise North Chennai waste is getting dumped at எங்க பாது I forget that name. Any of you from North Chennai? Kodungayur. There is a vast deposit land, or is called Kodungayur plant. This entire areas are now dumped. Otherwise, you can see mountains of this waste. Instead, we can try to just utilize the waste. Utilize the waste. First thing is to refuse any plastic. The major thing is, of course, the plastic material. Not only plastic, and also this electronic wastes are now seen in large amount. And also, you can also try to recycle. Try to use your wet waste. So, whatever the kitchen waste, if you can simply allow it to compost, they will turn to a nice manure in a period of about 2-3 months time. Of course, I am trying this for the past 1.5 years. I could have. My flat is a relatively palay flat, older flat, constructed some 30 years back. So we have a lot of soil available around the flat. So what I'm doing is I'm simply saving depositing keeping these contents in a bucket, and after about 2-3 weeks time I am simply dumping these contents in the soil. So by that way, this wet waste are turning to a nice compost. So that compost you can give it to any plant materials. Of course, I could develop a nice garden around my house. Maybe over class 11 I will show that thing. Over class 11 I will go around my plant and show you this my garden. Which of course this gardening is possible because of the corona. Thanks to corona, the last year only I started this activity. Last year this entire surrounding was simply consisting of debris. Now I could remove that debris, and I could make the soil to a nice fertile soil. And not only soil is now good, I could also get a lot of greens. That means kirai, a lot of kirai. What is it? The kirana is here. This palakirai and what is it? I forget the name. A lot of greens I'm getting, and also this papali. I could get a lot of papaya. And even I could grow this murunga maram, what is it? Drumstick, yeah, right. And even banana plants. So these are all possible because of utilizing the waste and converting the waste to nice compost. So this compost is nothing but your nice organic fertilizer. So whatever the produce available here are, I can say simply they are organic produce. So in that way, you also please try to do that. Those who could afford, at least some space is needed, or even you can try to compose the contents in your terrace also. Container you can keep on dump your wet contents. With about some 2-3 months time, this wet contents will be simply turning to a nice fertilizer. Because periodically you can stir the contents by aerobic composting is actually won't generate any harmful gases. Whereas anaerobic composting, which is happening in the what is it? The septic tank, these village people, they used to have a septic tank, or even the rural area, they have this septic tank. So the septic tank is actually decomposition process, which is anaerobic digestion. Whereas aerobic composting, which is anaerobic composting will lead to generation of gases like hydrogen sulfide or methane generation. Of course, there is also a possibility for getting methane also. You can even use it for any heating application also. Okay, this and all we'll discuss in the coming class. So there is a lot of opportunities for chemical engineers, to simply say. Simply from the morning to night, all the products, whatever you see or use are based on chemical engineering. Without chemical engineering, it is very hard to survive now. Okay, so whatever the things, what toothpaste, oil, all the things are chemical engineering, the product of chemical engineering. So in that, in every sector, there are employment opportunities. So no need to worry. So even the recent times, the girl students are much preferred for the design industry. Because it's repetitive jobs can be easily done with this design and employability are good for girl students now. Earlier it was not there. Otherwise, my classmate, I can say only one girl student. Even not only for my batch, my junior and senior batch, she was the only girl. Of course, she's named Nitya. Yeah, of course, currently she's in working in some research industry. Okay. Okay, I will continue this discussion in the coming class. Of course, these contents are available in the soft copy in LMS itself. இப்போதைக்கு attendance எடுத்துட்டு class முடிச்சிடலாம். Thanks pa. 54 students, good number. ஒரு ஆள் தான் இல்லையோ? Okay, because of any illness. Okay. யார் ஒரே ஒரு ஆள் மட்டும் நம்ம தெரிஞ்சுக்கலாமா? Then I will finish the attendance. யார் பார்த்து ஒரு ஆள் இல்லாத ஆளு? Can you please name the person who is missing in the class now, so that I need not take attendance now, because already 10:45 now, so you need to get prepared for the other class. Okay, attendance for everyone I can give, no problem. See you all in the coming class. That means on Monday. Before that, I remind you to work out this heat generation from a sulfuric acid industry, and how much is the power production possibility for 100 tons of sulfuric acid getting produced per day. Okay, you try to make a workout, simple workout, maybe maybe not more than a single page. So how to do that? Choose a basis of 100 tons of sulfuric acid getting produced, for which how much sulfur is needed, and for 1 mole of sulfur, how much is the heat generation, and how much sulfur is getting burnt. So based on which you can say about the heat generation. But how to convert that to steam? You can take the what is it? Latent heat of steam. So so much of heat generation, how much is the steam generation possibility? Otherwise, you can, whatever the heat generated will be used to raise water to steam, and from steam to electricity, the conversion you can take it as 1/3. So by this way, you try to work out. Let me see how you are working out in the next week. Okay, try to finish that activity. I will try to. I will make a link for uploading this calculation in the LMS. Okay, thank you all. See you in the next class on Monday.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. See you all.
Thank you, sir.
See you all.
Thank you, sir.
Super. Thank you. Okay, close பண்ணலாம் நினைக்கிறேன். Since there is no query from your side, I will stop sharing and also end the session. Thank you, Pa.